Types of ionizing radiation. There are three types of radioactive radiation, which are ionizing radiation, are alpha, alpha radiation. Here's the symbol for alpha, and beta radiation. This is symbol for beta, and gamma ray. This is symbol for gamma ray. Okay, let us look at the characteristics one by one. The first one is natural characteristics. Alpha radiation, alpha. Alpha, what is alpha? Alpha is actually nucleus. Okay, nucleus. Nucleus of what? Nucleus of helium. Understand? Okay. As we know that we have um, nucleus. The nucleus consists of proton. Okay, proton and neutron, right? And then we have electron orbiting it, right? Okay. Here we have electron, two electron circling it. Something like this. Okay. So what is alpha? Alpha is actually the nucleus of this atom, nucleus of helium. Okay, that is alpha. Okay. The next one, beta. What is beta? Beta is actually an electron, high speed electron. And then what is gamma? Gamma is a type of electromagnetic wave. Electromagnetic wave. As we have discussed before last week, we have electromagnetic spectrum. Okay, here is it. This is electromagnetic spectrum. Okay, so electromagnetic spectrum. And here is gamma ray. You see that? In electromagnetic spectrum, we have other types of wave. For example, a radio wave, infrared, microwave, visible light, ultraviolet, X-ray, and one of them is gamma ray. So gamma ray is a type of electromagnetic wave, and you can find it in electromagnetic spectrum. So this is gamma ray. And then alpha radiation. What about the charge? Charge of alpha particle. The charge is positive. Can you tell me why? Why the charge of alpha particle is positive? As I mentioned earlier that alpha is the nucleus of helium. So in the nucleus we have two proton and two two neutron, right? So proton is positively charged from here, and neutron is neutral. So that's why the nucleus is positively charged. That's why the charge of the particle is positive. Understand?
Yes, sir.
Okay, good. And then beta. Beta radiation. Beta radiation is negative. Why is it negative? Because it is electron. And gamma ray is neutral. Okay, because it is a type of electromagnetic wave. So it's just neutral. Ionizing power. High ionizing power for alpha radiation. Why this happens is because the mass, okay, the mass of uh, nucleus is high. So it has high ionizing power. And beta radiation is moderate because the mass of electron is small compared to nucleus. So it has lower compared to alpha radiation. but it is higher than gamma ray. Gamma ray has lower ionizing power. So what is ionizing? Do you understand? Do you remember what is ionizing? This is what we have discussed last week. So when particle passes through air molecules, then you can see that electron from the atom will be separated, and then we have ionized air. So this is what we call ionizing. So between the three radiation here, so alpha has the highest ionizing power. Okay. Okay, the next one is penetration power. Okay, penetration power. Okay, we have three types of radiation. You can see the red dot, which stands for alpha particle. Blue dot stands for beta particle. And the yellow wave is not yellow. The purple wave that you can see there represents gamma ray. From here, we can see that alpha particle will be stopped by a piece of paper, but electron still can pass the piece of paper, and also the gamma ray also can pass paper, but beta will be stopped by 3mm aluminum. Okay, by beta can be stopped by 3mm aluminum, but you can see here, from here you can see that gamma ray still can pass aluminum. Okay, understand? And then last one here is lead. Lead can stop gamma ray. Okay, lead can stop gamma ray. So you cannot see any other types of radiation here because all of them has been stopped. And gamma ray has the highest penetration power and can be stopped by lead. And the thickness of the lead should be around 10 centimeter and above. So we can say that penetration power for alpha radiation is the lowest. Beta radiation is moderate, and gamma ray is the highest. Okay, what about deflection of electric field? Okay, remember this is electric field because there are two types of field. The first one is electric and the other one is magnetic field. So let us look at deflection by electric field. So when we talk about electric field, so we must have positive plate, which is negative plate, which is connected to negative terminal of our source, and we have positive plate over here at the bottom, which is connected to positive terminal of the power source. Okay, now look at the deflection here. You can see that gamma ray has no deflection. It still moves in a straight line. So why this happens? Because we mentioned earlier that it doesn't have charge. Perhaps remember this. Look at the charge of particle. Gamma ray is neutral, right? Since it is neutral, so it is not affected by electric field. So we'll move straight on in a straight line. And then we have the next one, which is alpha particle. So alpha particle we have discussed just now. Alpha particle is positive. Okay, alpha particle is positive. That is why it is deflected towards negative plate. You can see here alpha here is deflected towards negative plate because alpha itself is positively charged. And then the last one is beta. Beta is actually high speed electron. So electron is negatively charged, so it will be attracted towards positive plate. That's why you can see it is bending. Okay, you can see the curve there. It shows that it is deflected towards positive plate. But you can see here that the deflection of beta is much more. Okay, you can see the curve here is much more. Okay, can you tell me why this happens? The deflection of beta is much more compared to alpha. It has something to do with the mass. Okay, mass. So we have learned already that electron has lower mass. That's why it can easily be deflected because of the mass of beta is very low, so it can easily be deflected. But alpha has higher mass. That's why it is deflected not so much compared to beta. Because alpha is heavier. It has higher mass, so it takes a little bit longer time to be deflected towards negative plate. Any question about that? Okay, that is about deflection of electric field, deflection of radiation in electric field, and the next one is deflection in magnetic field. You see here, deflection of magnetic field. Okay. Actually, how do we determine the direction of deflection is by applying left-hand Fleming rule. But however, you do not learn it yet. Okay, so you just look at it, and maybe for this moment you can just memorize that alpha is deflected like this. You can see in the diagram here. And gamma is still traveling in a straight line because it has no charge. Actually, in this case, it is not deflected. This is what we can understand from this diagram. It is not deflected by magnetic field. And you can see beta is deflected downwards like this. Okay, any questions so far? Okay, the next thing is sources of ionizing radiation in environment. Okay, we need to know where it comes from. We are talking about the source of radiation. Okay, the source of ionizing radiation in the environment. In the environment, sources of ionizing radiation are classified as natural. Okay, can be natural source of ionizing radiation and man-made sources. Just like this, you can see we have natural and we have man-made. So natural, for example, cosmic rays. Cosmic rays. So cosmic rays here refers to stars, galaxy, and so on. So stars and galaxy, they produce radiation, and the radiation can reach surface of Earth. So that is why we have radiation, which comes from the space. But we have electromagnetic field around the Earth. That is why the amount of cosmic rays that reach us can be reduced. Okay, and another one is background radiation. Background radiation, for example, comes from the ground. Okay, because ground contains minerals, rocks. They produce radiation also. Okay, something like rocks. Okay, they produce radiation. So we call this background radiation. So this is the natural source of radiation. And we have another one which is man-made. Okay, this one, for example, is nuclear accidents. Nuclear accidents. Okay, nuclear accident also can is a source of radiation. Usually, this happens in nuclear power plants. When the nuclear power plant is damaged due to earthquake, for example, and then there will be source of radiation which is leaked to the environment. So people who live nearby will need to be evacuated. Usually, nuclear power plant is made far away from residential areas. And then the next one is nuclear test. This is usually related to nuclear weapon. Okay. And the next one is use of radioisotope for medical purposes. Okay, and if you go to radiology department in the hospital, you need to be a bit careful. And usually, safety measures is taken there, where not everyone is allowed to enter X-ray room because it has radioactive radiation. So this is a type of man-made um, radiation, and another one is background radiation also. Okay, background radiation in this case is where people take that radioactive sources from the ground and bring it somewhere else. Maybe bring it to the lab for test purpose, and then we have background radiation. So that's one example. Okay, any question?
No, teacher.
No, okay, good. Okay, you can look here. Cosmic ray, background radiation. Okay, I have explained this already just now. Next one is unit of dose rate measurement for background radiation. Ionizing radiation that is absorbed from the human body will damage body cells. Due to this, the biological effects from ionizing radiation on human body is measured in a quantity known as dose. The dose of 1 SV is equivalent to 1 joule of ionizing radiation energy that is absorbed by 1 kilogram of living tissue. The unit of background radiation dose that is commonly used is microsievert per hour. Okay, this is the unit used. However, this is only information for you. You don't have to worry about this. Study, okay, before that, let us see. So this is the reading in the garden, which is the value is 0.12, and this is 0.07 in a school compound. So school is a safe place for you because the amount of radiation is very low. Okay, next one. Safe background. Background radiation or ionizing radiation dose of less than 0.2 microsievert per hour. Okay, this is the normal. Remember this. This is normal level or safe level. So when you compare to this is 0.12. So this is smaller than 0.2, and this is also smaller, which is 0.07. So these two places are safe for you. Based on photograph 8.2, the garden and the school compound are safe. This I mentioned earlier. The estimation of dose rate of ionizing radiation from various sources in daily life are shown in figure 8.1. Identify which sources are safe for an individual. So we can see here, okay, maybe you can pause this video later to see which one is dangerous. So from here, we can see that this one is dangerous, 5.5, right? And K grade is 55 ED. Okay. So this one is not safe. X-ray is not safe. So make sure you stay away from uh, X-ray room unless you are the patient. So you need to go through this process. Risk from exposure to natural ionizing radiation. Okay, this part you just need to read and understand it, but I'm not going to read everything here. You can watch it. You can pause the video later and read it. And this one also, you can read it yourself.